The Andromeda Galaxy played a crucial role in reshaping our understanding of the universe, challenging the long-held notion that Earth occupied a central position in cosmic affairs. This watershed moment highlighted that the Milky Way, our home galaxy, was just one of countless others strewn across the vast expanse of space. Advancements in observational technology, particularly through instruments like the James Webb Space Telescope, have allowed us to peer deeper into the cosmos, unraveling the mysteries of Andromeda. However, recent revelations from data captured by the James Webb Telescope have upended many long-held beliefs about this neighboring galaxy. Over a century ago, the prevailing view of the Milky Way was that of a faint, diffused band of light stretching across the night sky. This perception, influenced by the limited technological capabilities of the time, hindered astronomers' ability to discern individual stars within our galaxy. Various beliefs persisted, often associating the Milky Way with the epicenter of creation, where the celestial and terrestrial realms converged. It wasn't until the 17th century that our understanding of the Milky Way underwent a revolutionary transformation, thanks to Galileo Galilei and his pioneering work with a telescope. Galileo's observations revealed the Milky Way as an expansive collection of stars, planets, and celestial bodies dispersed throughout space. Building on Galileo's insights, Thomas Wright proposed a groundbreaking hypothesis in the 18th century, suggesting that the Milky Way was not a random scattering of stars but rather a flattened disk with our solar system nestled within its confines. However, it was the observations of Edwin Hubble in the early 20th century that truly reshaped our cosmic perspective. Using the 100-inch Hooker telescope at the Mount Wilson Observatory, Hubble identified distant nebulae beyond the Milky Way, demonstrating that these were distinct galaxies in their own right, each containing billions of stars. Among these galaxies was the Andromeda Galaxy, M31, one of the closest to our own. Andromeda's history of observation dates back centuries, with records of its existence found as early as the 10th century, when Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud. Despite the lack of telescopic instruments, al-Sufi's keen observational skills allowed him to identify Andromeda as a celestial entity separate from the familiar stars dotting the night sky. Detailed observations of Andromeda began in earnest in 1612, when Simon Marius provided a more comprehensive description based on telescopic observations. Later, in 1764, Charles Messier catalogued Andromeda as M31, though he unwittingly attributed its discovery solely to Marius, overlooking al-Sufi's earlier identification. Significant strides in understanding Andromeda were made in 1864 when English astronomer William Huggins made groundbreaking observations, further elucidating the nature of this enigmatic galaxy. Huggins' observations of Andromeda's spectrum marked a pivotal moment in understanding this galaxy, as he discerned that its spectral signature differed from that of a typical gaseous nebula. This paved the way for a deeper exploration of Andromeda's true nature. Andromeda, despite its immense size, is estimated to have a mass between 1 and 2 trillion times that of our Sun. This colossal cosmic structure, residing relatively close to us in the expanse of space, has intrigued scientists for centuries. With an estimated age of around 10 billion years, Andromeda is considered ancient in cosmic terms, hinting at a rich history of formation and evolution. One intriguing aspect of Andromeda's origin is the hypothesis that it formed through the merger of several smaller proto-galaxies, contributing to its current massive structure. Over billions of years, the Andromeda Galaxy has undergone a dynamic evolutionary process, shaped largely by galactic mergers driven by the force of gravity. These mergers, common throughout the cosmos, have played a significant role in the growth and structure of galaxies like Andromeda. For a long time, astronomers believed that Andromeda was significantly more massive than the Milky Way. This misconception stemmed in part from how Andromeda's size appears immense from Earth. However, recent research has revised these beliefs, showing that the masses of Andromeda and the Milky Way are much closer than previously thought. Despite the reassessment of its mass, Andromeda's vast physical dimensions remain a point of agreement. With a diameter of approximately 220,000 light-years, Andromeda surpasses the Milky Way in size, occupying a significant region of space. Understanding a galaxy's mass requires sophisticated observational techniques due to the intricate systems of stars, gas, dust, and dark matter. These components, especially dark matter, are difficult to measure directly, posing challenges for astronomers. One of Andromeda's most intriguing features is its active galactic nucleus, a highly energetic region powered by a supermassive black hole. Observations, especially with advanced telescopes like the Hubble Space Telescope, have revealed intense emissions from the nucleus, marking dynamic processes occurring at the heart of the galaxy. The mass of Andromeda's supermassive black hole is estimated to range from 110 to 230 million times the mass of our Sun. Similar supermassive black holes are found in the centers of most galaxies, including our own Milky Way, and have profound effects on the surrounding stars and gas. When matter ventures too close to the supermassive black hole, it forms an accretion disk, a swirling ring of material that heats up and emits radiation, contributing to the brightness of the galactic nucleus. Near the black hole, gravitational forces cause nearby stars to cluster tightly, further enhancing the brightness of this region. The black hole's immense gravitational influence pulls stars into elliptical orbits, much like the planets in our solar system orbiting the Sun. In addition to its supermassive black hole, Andromeda hosts an abundance of globular clusters, which are dense groups of stars orbiting the galactic center. These clusters, estimated to number around 460, offer insights into Andromeda's cosmic history and its interactions with smaller galaxies. Over billions of years, Andromeda has likely engaged in galactic cannibalism, assimilating stars and matter from smaller galaxies that fall within its gravitational influence. Recent observations suggest Andromeda may be undergoing a transformation into a ring galaxy, a rare type of galaxy characterized by a bright ring of young, blue stars surrounding a less luminous core. If confirmed, this would mark a significant change in its structure and highlight the dynamic nature of cosmic evolution. Ring galaxies are rare, with only about 1 in 10,000 galaxies classified as such. There are two primary types: O-type ring galaxies, which feature smooth, regular rings around a central nucleus, and P-type ring galaxies, which have more irregular, off-center rings. Ring galaxies are often thought to form through galactic collisions or by a smaller galaxy passing through the center of a larger one, triggering the formation of a ring-like structure. Examples of ring galaxies that have formed through such collisions include the Cartwheel Galaxy and ARP-147. These remarkable phenomena continue to inspire further exploration, deepening our understanding of galactic formation and evolution in the universe. The eventual collision between the Milky Way and Andromeda galaxies presents one of the most fascinating events in cosmic history. Astronomers predict that this colossal galactic merger will begin approximately 4 billion years from now, culminating in the formation of a new supergalaxy, playfully nicknamed Milkomeda or Milkdromeda. Despite the whimsical names, this merger could have profound consequences for both cosmic structures and life on Earth. As the two galaxies draw closer, their immense gravitational forces will begin to distort each other's shapes, triggering tidal interactions. This process will result in the exchange and mixing of stars, gas, and dust between the two galaxies. Eventually, these interactions will cause the galaxies to overlap, leading to massive bursts of star formation as gas clouds collide and compress. New stellar nurseries will emerge, generating clusters of stars that will illuminate the newly formed galaxy. However, this merger will not be without disruption. The gravitational chaos could have significant effects on our solar system and potentially on Earth itself. Although the Sun is expected to evolve into a red giant in about 5 billion years, well before the merger is complete, changes in the solar system's environment due to gravitational forces could impact Earth's climate. This might lead to shifts in weather patterns, biodiversity, and ecosystems, potentially threatening habitats and causing local extinctions. An increase in cosmic radiation during the merger could also impact Earth's atmosphere, affecting essential processes like the ozone layer. These changes could have cascading effects on Earth's ecosystems, altering migration patterns and leading to competition for resources among species. While some organisms may thrive under the new conditions, others may struggle, leading to shifts in biodiversity and the possible extinction of certain species. Although this cosmic event seems catastrophic, it's important to remember that it will unfold over billions of years. By the time the merger is complete, an estimated 6 billion years from now, the solar system may no longer be habitable. If life still exists by then, it will likely be vastly different due to evolutionary changes over such a long span of time. Whether our solar system is ejected into intergalactic space or incorporated into the new supergalaxy remains uncertain. The new galactic structure will also influence the stability of habitable planets. Gravitational disturbances during the merger could affect planetary orbits, potentially making it difficult for life to survive in the merged galaxy. If new forms of life do arise, they would likely evolve to adapt to the specific conditions of their environments, creating organisms distinct from anything we know on Earth today. Ultimately, the merging of the Milky Way and Andromeda underscores the dynamic nature of the cosmos, where galactic collisions and cosmic evolution continue to reshape the universe. While the future of life within the new galaxy remains uncertain, this monumental event offers tantalizing possibilities for new star systems, planets, and perhaps even forms of life.